Welcome to
FunMath number 159.
FunMath number 159. We're in the review section for Chapter 8 of Art of Problem Solving. And by coincidence, last night with your brother, I did a really neat problem. And Chapter 8 of Art of Problem Solving is algebra books about lines, and I wanted to show you a linear relationship in this picture. Okay?
Yeah.
The small rectangles have perimeter 12. Find the perimeter of the large square. Okay, and what I forgot to write, because I was writing too quick, is that all these rectangles are the same. Okay?
Yep.
Now, what does it mean that for a rectangle to have perimeter 12? If I just draw a rectangle like this, what does it mean that that rectangle has perimeter 12?
Well, it means the side lengths can be 1 and 5.
Means they can be 1 and 5. Why does that make the perimeter 12?
Because 1 and 5 adds up to 6.
Okay. Do they have to be 1 and 5?
No, they can also be 2 and 4. And 3, 3.
Okay. Can they be anything else?
Well, 4, 2, and 5, 1 would be the same thing.
Yeah. Do you have any other suggestions for what?
6, 0.
It could be 6, 0. That's interesting. Anything else? Think a little bit. What else could it be?
Well, these two sides have to add up to 6.
Oh, interesting. Okay, so why don't you write an equation that says that?
So x plus y is 6.
All right, which one are you going to call x?
I'll call the first one, the 1x.
Okay. What is that red thing you're holding in your hand?
Pen.
A pen. Oh, okay. So why don't you write which side? Write an x somewhere. Anywhere. Okay, x and y. Okay, very good. And we have an equation that says x plus y equals 6. Okay? Now, do x and y have to be integers?
No.
X could be a half, right? What would y be?
We have half and 5 and a half.
Okay, so we actually learned about equations like this. Okay? And if we draw our x and y's on here, I'll just do it real fast, because these are all the same.
Yep. They're supposed to be anyway.
What's the perimeter of the large square?
Well, we have 4y. It's 4y plus 4x.
Okay, so if x plus y equals 6, what's 4x plus 4y?
It's 24.
It's 24. So we have an interesting thing. This is a line, right? So solving the perimeter is fine, but solving the perimeter, or solving for x and y, produces something that's pretty neat. If x plus y equals 6, this is a line that we can put in standard form, y equals or slope-intercept form, y equals minus x plus 6.
So the slope would be minus 1.
The slope is minus 1. The y-intercept is 6. So when x equals 0, y equals 6. What about when y equals 0? What's x?
Well, when y is 0, x is minus 6. 0 is minus 6 plus x.
So you think it's minus 6, okay? So is this our line?
No, that's positive.
Interesting. Well, see what went wrong. When x equals 0, what's y?
Y is 6.
Okay. When y equals 0, what's x? What's that thing you're holding in your hand?
A pen.
Oh, a pen.
0 is minus x plus 6. So, it's x is 6, because minus x is minus 6.
Oh. Minus x equals minus 6. See how writing things down is a little bit better than doing them in your head? Because that way you can understand where the mistake was. Before, we didn't know where the mistake was. Okay, so here's our line. Oop, big dot, Jerry. Okay. So this line helps us understand, like, for example, if x is 1, y is 5. If x is 2, y is 4. Now those are the ones you found, but x could be 1.5 as well. Could x, in our problem, could x be minus 1?
Well, minus 1, no.
Because it's not, minus 1's not a distance. So really, we should stop there and stop there, but we still have a linear, what's called a linear relationship. Now there's an interesting question I could have asked, what about the area of this object? Okay. Well, it's y high, except for we have to take away this x here.
Yeah, so
It's y minus x high, and it's y minus x long, so it's a square. So the area of that center square is y minus x times y minus x. Now that's interesting.
Yeah.
Because we know that y plus x equals 1, or 6, sorry. Or y equals 6 minus x.
So you can substitute the y's.
Okay, so I get, bringing this equation down here, I get 6 minus x times 6 minus x, which is 6 minus 2x squared. Now that's going to produce a very interesting graph for my area. Now remember, x can start at 0, and it can be as high as 6. But let's look what happens. Sorry, I'm out of room a little bit here. Here's 0, 1, 2, 3, 4, 5, 6. We'll just pick some. When x equals 0, this is 6, so this would be 36. When x equals 1, I get 6 minus 2, which is 4 squared, which is 16, so it's going to be down maybe here. When x equals 2, I get 6 minus 4 squared, so 2 squared, which is 4, so that's down here. When x equals 3, what does this equal?
So it's 6 minus 6. It's 0.
It's 0. That should tell us something interesting geometrically. When x equals 3, y equals 3. Remember, because I have to add up to 6. So I have a picture with 4 squares, and there's nothing left in the middle. When x equals 4, I get 6 minus 8, which is minus 2 squared, which is 4. When x equals 5, I get 6 minus 10, which is minus 4 squared, which is 16. And when x equals 6, I get 6 minus 12, which is minus 6, so I get 36 squared. So I get this interesting shape here.
Parabola.
Definitely not a line. And I gotta use big dot theory in a couple places. So it's interesting. There's a lot of neat algebra living inside of this problem too. And this is the kind of stuff we're going to be studying starting in chapter 10. We got one more chapter to go.
Yep.
There we go. Okay, so that was fun. That was a fun little way where linear relationships come in other unexpected ways.
Yeah.
All right, good job, sweetie.